This problem asks us to use logarithmic differentiation to find the derivative of this function. Now we are unable to use any of our familiar rules here. This is not a situation where we can use the power rule because we have variables in the exponent. This is also not a situation where we can use our rules for exponential functions because we have variables in the expression that is raised to the power. So neither of those situations, this is neither of those situations. So instead we have to transform this into something that we can work with. And the key fact to remember is that if we take the natural log of some expression raised to a power, then by the properties of logarithms, we are allowed to bring that power down in front and multiply by the natural log of that expression. So we are going to use this property to transform this function into something that we can work with. So the first step is to just take the natural log of both sides. Once we've done that, we go ahead and use the property that was just discussed to transform the right side into x times the natural log of x squared plus 1. So at this point, we have transformed the situation into something that we can work with, because from here we can differentiate in a manner similar to implicit differentiation, right? So the next step is to just take the derivative with respect to x of both sides. Okay. So taking the derivative of both sides with respect to x, let's focus on the left side. Y is a function of x, so when we take the derivative of the natural log of y, that is going to be 1 over y, and then we have to chain on the derivative of y, right? So we have to chain on a y prime here, and this is the part of the problem that is reminiscent of implicit differentiation. On the right side, we're taking the derivative of the product of two functions. So we get the first times the derivative of the second. That will be 1 over x squared plus 1. Chain on the derivative of the argument, which is a 2x here. And then add the second times the derivative of the first. The derivative of x with respect to x is simply 1. Okay. So after we've transformed this into something that we've worked with, that we can work with, rather, take the derivative of both sides with respect to x in a fashion that is similar to implicit differentiation, and then the rest of the problem is just solving this equation for y prime. So to get y prime by itself, I simply have to multiply the left side by y, so I'm going to multiply both sides by y. And we get that y prime is equal to y. And I'm going to go ahead and simplify this right side at the same time. We get 2x squared over x squared plus 1 plus the natural log of x squared plus 1. The final step, now that we have y prime by itself on the left side, the final step, since we know what y is explicitly in terms of x, we go ahead and make the substitution of this expression for y. And there we have the derivative of y with respect to x.